I'm Anil Kumar. In this video, we will learn about radian measurements. To begin with, do you know what is the default unit for measuring angles? Well, if you think it is degrees, you really have to watch this video. We are actually going to discuss the topic in details with our student, Chelsy. And I hope all those who want to learn about radians, for them, this is going to be one of the best videos. We'll learn what radians are, what is one radian, how do we define it, a bit of history behind it, relate the measurements of degrees with radians, find arc length, and derive formulae for sector area and segment area. Let's have the class with Chelsy now. Hi, Chelsea. How are you doing?
Hi, sir. I'm good. How are you?
Very good, very good. So, today, what do you want to do?
Today, my class started trigonometry, so I want to learn about radian measure.
Radian measure. So, how much do you know about radian measure?
We just started, so not very much.
Not very much? Okay, that's fine. No problem. So, we'll start from right from the very beginning. So, that should be very useful for anybody who is going to start trigonometry in radian measurements from the very beginning, right? Earlier, you have done trigonometry, so you know how to solve some questions or work with trigonometric ratios, especially when you're working in degree measurements, correct?
Mhm.
Perfect. So you know what SOHCAHTOA is, what is the cast rule, sine law, and cosine law. Perfect?
Yeah.
Right. So after that, radian measurements, let's take it up. So let me just share with you whiteboard, and then from there we'll begin. You can see my board?
Yeah.
Perfect. So, perfect. So, radian measurement. First question first. What is the default unit of measurement of angle?
Degrees. Right.
You said
Degrees.
degrees.
Yeah.
That is wrong.
Oh.
Radian measurements. So remember, radians is the default unit for measuring angles. Unfortunately, we actually discover this at the end of our school, right? And always work with degrees. You will now realize why radian is the default unit. In calculus, when you take up, all the measurements of angles will be done in radians. So basic laws which we follow in calculus or the derivatives and the limits, they're only applicable if trigonometric functions are measured in radians. So radians actually is the default unit for trigonometry. Is it okay?
Yeah.
So now you know that the default unit for measuring angles is radians, right? So radians is the default unit. You know what is the circumference of a circle?
2 pi r.
Perfect. So circumference is 2 pi r. If the radius is r, in that case, circumference is 2 pi r. Now we have a relation between the arc length, radius, and the angle. Let us say that the angle here is theta, r is the radius, and this is called the arc length. And let us say this arc length is a. if the angle is in radians, in that case, A is product of r and theta. If the angle is in radians, then the arc length is product of radius and the angle, which is made by the arc. We call this as angle subtended by the arc. You see, theta is angle subtended by the arc. So let's say this point is O and this is AB. So this arc will be called as arc AB. So that's the way to write down the arc. Well, this is a minor arc, the smaller one. Since it is smaller than semicircle, this is also referred to as minor arc.
Okay.
The other arc becomes the major arc. But to write down the major arc, we'll have to consider another point. Let us say the point is C. So in that case, arc ACB will be the major arc. So it is a nomenclature that for a minor arc, we can write just AB, 2 points, which are the two endpoints for the arc. But for the major arc, we have to include another point. So it's very clear, because every time you write AB, you're not very sure of, correct? Whether it's the minor arc or the major arc. So for major arc, we have to introduce the point C, correct?
Okay. Yeah.
Now look here. We are saying that the arc length is product of radius and the angle inscribed theta. Now, if arc length is full circle, that is the circumference, right?
Yeah.
So what is the formula for circumference? 2 pi r. And arc length is r theta, correct? So for full circle, what is the value of theta? Two pi, correct?
Mhm.
Arc length is r theta. Theta is 2 pi. Do you see for full circle?
Yeah.
So that is what it is. So if you go full circle, then that angle in radians is 2 pi. So the basic formula which you use for circumference, which is 2 pi r, do you see that angle actually is the radian angle, full circle angle? Do you see that?
Yeah.
You have been using this for a long time, since, junior classes, correct?
Mhm.
So 2 pi r is the circumference. Okay, so we have understood this part. Now, let me clear the screen. We'll continue with this arc length thing. So once again, let us say this angle here is theta, radius is r. Now, I'd like to introduce you to one more thing, that is conversion factor between the radians and degrees, because you're very familiar with degrees, right? So
Yeah.
full circle is what? How many degrees?
360.
So that means 360 degrees is equals to 2 pi radians, correct?
Mhm.
Or you can say 180 degrees is pi radians.
Yeah.
Now you have to remember one more thing, and that is radian is the default unit. So I could also write 180 degrees equals to pi. There is no need to write radians because
Okay.
that's the default unit, okay?
Mhm.
Sometimes we do write radians. I mean, we prefer, or RAD, we do write. But if it is not written, it means the unit for measurement is radius, okay, by default.
Mhm.
Now, let's do some exercise to convert degrees to radians. 180 degrees is pi. So what is 90 degrees? Half of that, right?
Pi over 2.
And what
Yeah.
is 45 degrees?
Pi over 4.
Simple as that. If I do 60 degrees, then 180 degrees is pi radians. 60 degrees is 1/3, right?
Mhm.
If you divide 180 by 3, you get 60 degrees. So 30 degrees will be pi by 6, half of 60 degrees. You
Yeah.
see, they're easily convertible. We can always write them in terms of pi. So these are the exact values which we have written for degrees in terms of radians. The value for pi is approximately equal to 3.14. Pi is irrational number, right? And its approximate value is 3.14. How do we find the value of pi? Well, we can do an experiment and then we can find. Okay, so we had C as 2 pi r, which could also be written as pi times the diameter, right? So what is pi equals to? Pi is circumference over diameter.
Um,
So that is the value of pi. So how can you find it? Well, you can make many circles of different diameters, correct? And accurately measure the circumference, let's say by putting pins and a thread around, correct? You can straight measure this diameter, and this ratio will be approximately 3.1 for
um,
any circle. And
okay.
that gives you the value of pi. Interesting?
Yeah, I didn't know that before.
Yeah, this is important to understand and visualize what pi is after all.
Yeah.
Now, the thing is that brings us back to how it actually originated. Egyptians were making so much of construction, right? And circle is a very basic thing for constructing.
Mhm.
They observed that the circumference is proportional to the diameter. If I increase the diameter, the circumference will increase, right?
Mhm.
And they worked out that the ratio is always constant, and they call that as pi.
Um,
So that is how pi has originated, and their measurements were accurate to, let's say, 4-5 digits, but 3.14 we will take for our rough calculation. Is that okay?
yeah.
So,
So,
yeah,
sorry, sir. Does that mean that like any circle, no matter what the circumference or diameter, is always going to have a ratio of
yes.
3.14?
Circumference to diameter has to be pi, because you know what diameter, circumference is pi times diameter, right? So you just rearrange this equation, get the result. Clear?
Yeah.
Perfect. Okay, so we have done the conversion, but we'll spend some more time on conversion. Let's convert degrees to radians for some angles, which are not that easy. What I'm trying to say is you may use calculator. For example, if I have 100 degrees, how many radians will that be? We know that 180 degrees is equal to pi radians, correct?
Mhm.
So if I have to convert 100 degrees to radians, what should I do? Well, I want radians on the top, right? So I'll multiply by pi and divide it by 180. Is that clear?
Yeah.
So degree will cancel and I'm left with radians as my units. So you can use your calculator to find this particular answer. Is that okay? So you can say 100 pi over 180. You can simplify this. Dividing by 2, we get 5 over 9 pi. You can see this, right? So 5 over 9 pi is 100 degrees, correct? Similarly, if I say 2 radians, so how will you convert radians to degrees? Tell me.
So will it be 180 over pi?
Correct. So 180 is in degrees and pi is in radians. So radian will cancel. What is left is degrees. Is that okay?
Yeah.
So 360 over pi in degrees will be the conversion. So very simple, right? So if you have degrees, and if you want to get into radians, Then what do? Well, in that case, you times it by pi and divide by 180, right? So the factor is pi over 180. However, if you want to do the reverse thing. 180 by pi, correct? And get the reverse thing. Is that clear to you?
Yes.
Perfect. Now, how much is 1 radian in degrees? That will be 1 radian will be multiplied by 180 degrees and divided by pi, correct? Can you use your calculator and find this answer?
$57.29.
So approximately 60, slightly less than 60, right?
Yeah.
57.29, you are right. That gives you an idea. So what we're trying to say here is visualize. This is 0 and that is pi, correct? Half circle, correct? So if I
Yeah.
go full circle, this will be 2 pi. Perfect?
Yeah.
And 1 radian is 57 degrees. This is like 3.14. Let me write numbers here so that 3.14, right? So times 2, 6.28 approximately. So if I say that the measurement of angle is approximately 5 radians, that means you are in quadrant 4, right?
Yeah.
If I say it is like 2 radian, then 120, you are in quadrant 2. 60 is approximately 1 radian. So remember that. More than 3 radians, let's say 3.5, will be in quadrant 3, correct?
Mhm.
And what is half of 3.15? 14? So it'll be 1, and then we are dividing by 2, right? So 11, we got 1.5, 10, 40, 1.57. So anything less than 1.57 will be in quadrant 1. So that gives you an idea of radian measurements, correct?
So what would be between 3.14 and 6.28?
Oh, this area,
Yeah.
quadrant 3 or 4, this area, right?
Yeah.
Yeah. So any value. But if it is more than 6.28, that means you are going more than a circle.
Right. Okay.
It's like 400 degrees. It's more than a circle, correct? Okay. Now, have you seen any protractor which is for measurement of radians? You have a protractor to measure angles in degrees, right?
Mm-hmm.
But not in radians, right? We haven't seen any. Do you think why it is so? We don't have a protractor to measure in radians?
I'm not sure.
Because Egyptians time they just used to do with ropes and nails, right? Old technology, right? Radians. Because it is too simple. See, we will now look into how simple the radian thing is, right? Look here. We just turned out, we converted some degrees into radians, correct? So we got some numbers. Now let us see, how do we plot that angle accurately without any protractor? Look here. This is 0 radians, correct? Pi radians, correct? This is pi by 2. And this is also 2 pi, correct?
Yeah.
So 1 pi, it is 1 pi by 2, 2 pi by 2, 3 pi by 2, correct? Now, if you have to draw pi by 3, this angle, how will you draw it? Well, one way is, this is full pi, right? I could divide it into 3 equal parts, correct?
Yeah.
Pi by 3 is a fraction, dividing pi into 3 equal parts. And once I do that, then see here, joining these lines will give me what? Pi by 3. Do you see that? How easy it is. So we get pi by 3, and that becomes 2 pi by 3. This becomes, we can write this as 3 pi by 3, which is also pi, correct? Extend these lines. 4 pi by 3. 5 pi by, sorry, 5 pi by 3. And this becomes 6 pi by 3, correct? Which is 2 pi. This makes sense. So easy. And quite accurate, correct?
Yeah.
Now, if you want pi by 6, obviously you have to do half of this, right? So I get pi by 6, correct? So this is 1 pi by 6. And half of this will be going through this. Let me just do half of these pi by 3s, correct? Okay. So we have 1 pi by 6. 2 pi by 6 is pi by 3. 3 pi by 6 is pi by 2. 4 pi by 6. 5 pi by 6. 6 pi by 6. 7 pi by 6. 8 pi by 6 is same as 4 pi by 3, correct? Cancel by 2, right?
Yeah.
9 pi by 6. This is 10 pi by 6. 11 pi by 6. And that becomes 12 pi by 6. Do you see that? How simple it is. You got all these angles right there. How about 45 degrees, which is pi by 4? Well, simple. Just divide this equally, right? Diagonal, correct? This is not very accurate on this side. Anyway, now I made it. So when I do this, this is 1 pi by 4, 2 pi by 4, 3 pi by 4, 4 pi by 4, which is pi, right? 5 pi by 4, this one. 6 pi by 4, 7 pi by 4, and 8 pi by 4, 2 pi. Do you see that? So we have got all these angles very easily. Do you see that? So it is just dividing into equal ratios to find your angle. You can do 7 pi by 8, divide pi into 8 equal parts, select the 7th one, 3 pi by 8, select the 3rd one. You see how simple it is? That is how we are going to actually sketch the diagrams with given radian values in pi, exact values. Is that clear to you?
Yeah.
Okay. So you have understood how to convert and how to sketch angles in radians. Now, let's get back to the circle and look into some radian measurement questions. So we have learned one thing just now, and that is arc length A equals to the radius times the angle when the angle is in radians. So it is same as like distance traveled, speed and time. Do you see that? So you can make a triangle here. You can say A is r times theta, just to remember. Now, this is A for us. Now, if I have to find theta, the radian value, then theta will be a ratio of A over r, correct?
Yeah.
Arc is a length and radius is also a length, same units, right? So length units. For example, both you can measure in centimeters. So what do you see? If I write, for example, centimeter over centimeter, it cancels, correct?
Yeah.
It cancels. So strictly speaking, radian is the ratio. Theta is the ratio. It does not have any unit, correct? Because the length unit and length unit will cancel. So it is just a ratio. Now, theta equals to 1. It means what? We know theta is A over r. Theta equals to 1 radian means that A equals to r. Do you see that?
Yeah.
So you can define 1 radian as what? 1 radian is the angle subtended by an arc whose length is same as that of the radius. You get the idea? So
Yeah.
if I make this arc same as that of the radius, kind of like this, if A equals to R, in that case, this is 1 radian. Do you see that?
Yeah.
So 1 radian is the angle subtended by an arc of length equal to the radius. Perfect?
Yes.
Very good. Now, let's do some questions. We'll now find arc length for given radius and the angle. Okay?
Okay.
You might need your calculator now. So in this diagram, we have the radius, let's say 5 units, and the angle here is given to you as pi by 3. Can you tell me what is the arc length A? Let's say this is in centimeters. So it'll be 5 times pi by 3 in centimeters. Clear?
Yeah.
So that becomes the exact value. You can always multiply with 3.14. So approximately 5 point something, right? Very close to 5. Is that clear?
Yes.
That is how you can find this. So this is your minor arc. What is the major arc length? That means this part. So for that, you know what this angle should be? 2 pi minus pi by 3, correct? So that'll be 2 pi minus pi by 3 or 6 pi minus pi over 3, which is 5 pi by 3. Clear?
Yeah.
So major arc length will be 5 times 5 pi by 3 or 25 pi by 3. Is it okay?
Mm-hmm.
So you can easily find the major and minor arc length. They will always add up to the circumference, which is pi times 2 pi r, correct?
Right.
Okay.
Yeah.
So that was simple. If the radian measurement is given for angle. Now, on the other hand, if I have this circle and now let's say I give you this angle as, oops. Okay, so we do it. Let's say this angle is 200 degrees for me. Then, can you find the arc length A for the radius of 10 meters? How much will A be?
So
The angle theta is given to you in 200 degrees.
yeah.
And so, how will you find A? So, A equals to R times theta. So, what can you do? Well, you have to convert the degrees to radians, correct?
Mm-hmm.
So, first convert theta from 200 degrees to radians. So, you'll multiply with what?
Pi over 180.
Pi over 180. So, you do this calculation, right? So, it both can be divided by 2. So, you get 10 over 9 pi. So, that is the theta value, correct? But we are interested in this angle, correct? So, that is 2 pi minus that. Or you could have done 160 and then do the conversion, correct? You could have done that also.
Mm-hmm.
You could find this as 160 and convert 160 into pi by 180 to get your answer, which will be same as we are calculating here, right? 18 minus 10 is 8 pi by 9. Clear?
Mm-hmm.
Which you are going to get here also. So when you cancel this, This is 9, this is 8. So you get 8 pi by 9. Clear? So either way you could work. So now when you know the angle basically is 8 pi by 9 and 10 is this radius, then arc length will be 10 times 8 pi by 9. Clear? So that is how units meter for the arc length. So if you are given angles in degrees, you can convert them into radians and find the arc length. Okay? So that is how we'll be finding the arc length. Now, we'll look into the area. So this time, I'm again making a circle with, this is called sector. This is called sector, correct? So we have a sector OAB. If I know that the radius of this is, let us say, 10, and the angle here is pi by, let's say 6, okay? Now pi by, let's make it 3. It's much bigger. So we'll take angle as pi by 3. Let's say theta is pi by 3 and radius is 10. So how much is the sector area? Well, to find the sector area, we know it is same in the same proportion as the angle, correct? What is the total circle area? Pi r square, you know that.
Yeah.
You know that pi r square, right? It's a default thing, right? Which is 10 square pi or 100 pi. Clear? Now the sector area should be how much? From the symmetry itself. See, circle has infinite symmetry. And from the symmetry itself, we can find the sector area. It is in the same proportion as the angle, correct? So we can say, well, 100 pi times this angle, which is pi by 3, divided by 2 pi. Because full circle area was 2 pi radian angle. Now we are looking into a smaller angle. So it is going to be much smaller in the same ratio. Right? So you can do this calculation. So pi and pi will cancel. 2 will go with this. We get 50 pi over 3. If this is in meters, then area will be in meters square. Now let us derive the formula. We have done one calculation, correct? Let's derive a general formula for area of the sector. So we are saying area of the sector is, you have to find the total area, which is pi r square, correct? Multiply with the angle, which is theta, divide by the total angle, correct? 2 pi. So we get the area of the sector. Does it make sense for any given angle?
Yeah.
And clear, pi and pi cancel. So half r square theta is my formula.
Yeah.
How easy it is. Do you see how mathematics is so simple with this radian measurement? Half r square theta. So we got the sector area, half r square theta. Okay. So we found sector area equals to half r square theta when theta is the angle. Okay. Let me make another circle. I love making circles. Okay, let's make this. And what we have here is radius, and this angle is theta. So we found, okay. Now the question here is, how do you find this is called chord. Area of the chord. Well, clearly, if I have AB is the chord, AB is also the sector, arc. So OAB is the sector. So we are talking about the sector OAB. Okay. Now, I have to find the area of the chord. So what do you think is the area of the chord? I have to subtract the area of the triangle from the sector area, correct?
Yeah.
Fine. We know the formula for sector area, which is half r square theta. And what is the formula for triangle area? Half base into height, right?
Mhm.
Base is AB for us. And height. How do I find the height? Okay. So I'll draw a perpendicular here, right? Let's say this is the midpoint. It has to be the midpoint. Why? Because radius is radius. Isosceles triangle, whenever you'll have an altitude, it will equally divide, right? These are congruent triangles, correct?
Mhm.
So we have a right angle, and definitely this angle will be theta by 2, correct?
Yes.
Because it's an isosceles triangle and the right angle will divide it into two congruent triangles. So we have angle of theta by 2 there. If that is the angle, and this is the point M, which is going to be midpoint, since these are congruent triangles, correct? So all the sides. Okay, now what is AM and what is OM? If you find that, we can write down area of the triangle is half AB into OM, right? Altitude. You can use trigonometric ratios. You remember sine theta and cos theta?
Yeah.
So AM is what? So we can write down here. What is sine of sine theta by 2? AM by OA is basically sine theta by 2, right? So AM is equals to OA sine theta by 2. OA is R, right? So R sine theta by 2. Is that clear?
Yes. Could you explain it one more time, just so I clarify?
If you look at this triangle, we are now looking at one of these triangles, any one you could select. Let's say this one, correct?
Mhm.
In this triangle, the opposite side and the hypotenuse ratio is sine theta. Correct? So sine theta by 2, the angle, which is sine theta by 2 here, is ratio of opposite side to hypotenuse. So cut over, right?
Yeah.
So in that case, sine theta by 2 is A to M divided by A to O. A to O is radius, right?
Yes.
So A to M we can find as AO times sine theta by 2. AO is the radius, R sine theta by 2. Is that clear to you now?
Yeah.
And A to B is 2 times AM, right? A to B is 2 times because they are equal, correct?
Yeah.
So I will write 2 R sine theta by 2 for AB. Clear?
Mhm.
Let me keep writing this. So we have half R square theta minus half and 2 times R sine theta by 2. Okay, now, what is the length of altitude OM? Well, it is the cos theta value, right? Because, cos theta by 2 is the ratio of OM, adjacent side, over AO, correct? So, we have OM as equal to R cos theta by 2. Is that clear to you?
Yeah.
So OM is R cos theta by 2. They are the two sides of right triangle. where the angle at the vertex is theta by 2. So one is sine theta, the other one is cos theta, correct? Times the hypotenuse of radius r. So that is the relation which we get. Do you see that? So in this relation, I could cancel these halves, and what do I get? R squared sine theta cos theta by 2, right? Okay. So that becomes our formula. But do you remember, you will actually soon learn another formula in double angle. You haven't really gone there. When you do compound angle formula, sine theta by 2. Actually, we can write, I'll leave the formula at present here, but I could always write this as, you will soon learn a formula, which is sine 2 theta. So there's less space here. Let me, sine 2 theta is 2 sine theta cos theta. So here we have, so we could use the double angle formula and complete this. But anyway, you do have a formula, which is half r square theta, and it will be minus half r square sine theta. I'll show you that proof later in a minute. But you can note down the formula. Half r square theta minus half r square sine theta. We'll go to a fresh page and then continue there. Okay?
Okay.
So let me erase this. So what I was saying here is that the triangle area so we are actually trying to figure out the chord area, correct? We call this as a segment. Sorry. So we'll say segment area equals to sector area, take away triangle area. Sector area is half r square theta, if this angle is theta. This is half. And the triangle area we just derived actually is half r square sine theta. So you will soon learn this particular formula, which is what we had was sine theta by 2 and cos theta by 2, right? 2 times. So, but this is the formula. So how do we derive it? Let me just give you the formula, but you'll learn later. We know what is sine A plus B is basically equal to sine A cos B plus cos A sine B. You are going to learn it in few classes. I mean, just in 2-3 days. So if I make A equals to B or B equals to A, if I write B equals to A, then it becomes sine A plus A, right? Equals to sine A cos A plus cos A sine A. Is that clear? Which is same as 2 times sine A cos A. Do you see that? 2 times sine A cos A is what? Sine 2A. A plus A is 2A. You get the idea? So now, if I make a small substitution, which is if A is equal to theta by 2, in that case, I get sine 2 times theta by 2 equals to 2 times sine theta by 2 times cos theta by 2. So that this is what? This is sine theta, right? 2 and 2 cancel, correct? We are left with sine theta. So sine theta is 2 times sine theta by 2 cos theta by 2. So we can replace that with sine theta. You see that derivation?
Yeah.
Very easy to remember. The segment area is, you can half r square theta minus sine theta. You see that part? So we have derived so many formulae in this particular class. We have also found how do we find the arc length, the sector area, and now the segment area. Perfect. Also, we have treated the triangle as a part of this derivation, and we know that the triangle area for any inside the circle will be half r square sine theta, if theta is the angle, correct? So easy formula to remember, this area is half r square sine theta. The outside area is half r square theta. And so the segment area will be difference of the two, and we can easily calculate. You get the idea how we calculated all this. Now with this information, we've got a lot of information now. So you should actually watch some of my videos and also practice questions from the book. So when I see your book normally, there are a couple of parts to this. Do you have the book?
Yes, I do.
So can you just share what is there in the first chapter? We'll just quickly go through it.
Okay. Right here.
Yeah, so connecting radians with degrees, you know the connection now. Pi radians is 180 degrees. We know this page. Next page. So these are the examples which are converting radians to degrees, and also we'll convert speed also later. Well, not today. Okay. Now look into the summary.
Here's a summary.
Yeah. Summary gives you the formula theta equals to a over r, correct?
Yeah.
And then 1 radian is what? When radius is equals to arc length. Do you see that part? So we did all that. Can you please read this part? Need to know for unit 1, chapter 1.
Yes. Need to know. Using radians enables you to express the size of an angle as a real number without any units, often in terms of pi. It is related to degree measure by following conversion factor. Pi radians equals 180. To convert from degree measure to radians, multiply by pi over 180. And to convert from radians to degrees, multiply by 180 over pi.
Perfect. Now, question number 1. What is the question? Can you please read the question?
A point is rotated about a circle of radius 1. Its start and finish are shown. State the rotation in radian measure and in degree measure.
Correct. So if the radius is 1, in that case, r is 1. So theta is arc length. Do you see that? Arc length and theta will be exactly same for unit radius. So therefore, many times we work with unit circle, where the radius is just 1 unit. So if in the first case, part A, the arc length is pi because the angle in radians is also pi, 180 degrees, correct? Do you see that? So likewise, we can very easily answer the question. In G, we have divided this circle into how many parts? We can say 1, 2, 3, 4, 5, 6. And so 4 out of 6, pi. Do you see the ratio? We can actually straight away work very easily and get all the answers for finding the relation between the arc length, radius, and so easy. Okay, question number 2. Can you please read that question?
Question number 2. Sketch each rotation about a circle of radius 1.
Simple as that. We just did, right? Approximately, correct? Now, important. If the angle is negative, it follows the same thing. Clockwise is treated as negative angle and counterclockwise as positive angle, just as you do in degrees, correct? Next question, please.
Number 3, convert each angle from degrees to radians in exact form, which we did already.
Next question.
Number 4, convert each angle from radians to degrees. Express the measure correct to 2 decimal places if necessary.
Correct. Use calculator. Question number 5, 6. 5, read.
5A, determine the measure of the central angle that is formed by an arc length of 5 centimeters in a circle with a radius of 2.5 centimeters. Express the measure in both radians and degrees, correct to 1 decimal place.
Easy, right? So you have to use A, R, and theta, right? And remember this, just make this triangle easy to remember that A is R times theta. Is it okay? So what is given to you? Determine the measure of central angle that is formed by the, you have to find the central angle that is formed by the length of 5 centimeter in a circle of radius, length of 5 centimeter in a circle of radius 2.5 centimeter. Do you see that? Easy?
Yeah.
So theta is ratio of A over R, right? So theta is A over R, just divide and get your answer. Now, 7, 8, you can very easily see convert degrees to radians and all those things. So all these questions, which is kind of end of the exercise, is very simple for you to do, right? So you can actually now do all the questions. And if there's any difficulty, you can ask me, right? And the next chapter, go further. Yeah, you can do all that. Next chapter.
6.2, yeah.
So we'll work with special triangles in the next class. Right. Further. So they are not dealing with area of sector and area of segment yet, which will be there in your test also as one of the difficult questions, correct?
Yeah.
So that might come, which we covered today, but that's very important for you to remember. Is it okay? Perfect. So we'll continue from here. Chelsea, is everything clear to you from today's class?
Yes, thank you so much.
My pleasure. Have a great weekend.
Thank you, sir. You too.
Bye.